Hello, my dear students. Welcome back to St. Joseph Composite PU College, Bijapur. I'm Rahul, chemistry faculty, and today I'm going to extend the topic solution. Was discussing the methods of expressing the concentration of solutions, and now the new term is here, that is molality. This term is quite important because this entire topic is dependent on the two important concentration terms. One is mole fraction, another one is molality. So molality is generally indicated by small m. You have to remember this one, the capital M for the molarity. Now, the molality can be given here as the equation. We can get an equation like number of moles, number of moles of solute, moles of solute, and that should be divided by the mass of solvent. That is mass of solvent. Solvent. I'm underlining here solvent because in the previous case we have taken in the molarity the volume of solution we taken, but here we have to take mass of solvent, the drastic change in the denominator, the mass of solvent, and that should be expressed in terms of kg, in kg, kilograms. Okay, this is the equation or generalized equation for the molality. Now we can provide here one visualization. So assume that you have a container, and in this container what you have to do, you have to add a small amount of water. Take the mass of water, so that equals to 1 kg. Usually the water is exist in the form of liquid. Obviously we have to measure in terms of volume, but also we can measure the volume in terms of mass if you know the density. Okay, and in that if you add 1 mole of any substance, 1 mole of any substance that get dissolved, if you add in the 1 kg of water, then we can write molality m, small m. The number of moles we added here is 1, and that is mass of the solvent we taken, that is 1 kg. That is 1 divided by 1, we get here 1 molal solution. The concentration of the solution is 1 molal. You have to call it as a 1 molal. Okay, this is in short we can call molality as molal. Okay, now assume that in the same way, if I take here 0.5 kg, the half kg of solvent for 0.5 kg of solvent is taken, solvent. In that case, what happens? M is equal to, that is molality is equal to, number of moles added is 1, and the mass of the solvent is taken, it is total of 0.5 kg, and is equal to, we get here 0. It is like you can say that 1 by 0.5. So instead of that I will write one more step here, 1 divided by, so 0.5 we can write here is 1 divided by 2, then it becomes here 2 molal solution. You just notice here one of the small you can say that hint here. When I reduce the mass of the solvent to exactly half, the concentration of the solution doubles. Okay, just visualize it. Initially you taken a 1 kg of solvent, and in that you added 1 mole of solute, you got 1 molar solution. This time you have to take half kg of water, and in that you have to add same amount, means 1 mole of solute, and you will get the double the concentration. Now I have one problem on this. We'll discuss that first. So here is a question that is provided here. To calculate the mass of solute, that is urea is provided, required to prepare 2.5 kg of 0.25 molar solution is required, and you have to calculate the amount of urea should be added to create a 2.5 kg of solution of the concentration 0.25 molar. Let's understand that how to calculate this. The first thing, we need a formula that is the molality equals to number of moles of solute, number of moles of solute, okay, and the whole divided by, we have to divide this with the mass of the solvent, mass of solvent in kg, kilograms it should be, in kg. And first few things we required here. The one thing is that that is the mass of the solute. Instead of that, we can calculate first the what is the number of moles are required, because in terms of molality in the formula we can see that number of moles are there, not a mass. And therefore what I will do that, I will calculate the first mass of the solvent, because the solution mass is given. Therefore first part, mass of solvent solvent. The very simple part, that is mass of solvent, we can get by subtracting mass of solution by the mass of solute. Mass of solute. Okay, this is simple formula. Mass of the solution is given, that is 2.5 kg. Instead of that, I will write here 2500 grams. I will write 2500 grams instead of writing kg, minus the mass of the solute we don't know, right? Here also we have to calculate the mass of solute is required, but we can keep it as a n into the mass of the urea. So let me take one simple explanation here. Let's go over here. You know that the number of moles can be calculated by the given weight. Let me take a WB is the given weight of the solute divided by molecular weight of the solute MB. And here we have the WB equals to, that is N into molecular mass of the urea or B solute. And in this case we have N2H4CO is there, that is 14, that is 28 plus 4 plus 28. So what do we get here? That is 60 grams per mole is the molecular mass of the solute, and this equation we have to use to calculate the mass of the solute. Okay, let's go with the equation. So it becomes here N into 60. This is the mass of the solvent. We got it. Okay. Once we get it, we make a relationship. For 1000 kg, or sorry, 1000 grams, it is 1000 grams. For the 1000 grams of solvent, so it contains n number, that is n, you can say that moles. Okay, but we required here 0.25. Here is 0.25 is there. Therefore, what we'll write, to get 2.5 kg of solvent, a solution of the concentration of 0.25, first we have to calculate the same thing for 1000 gram of solvent, and then we can write here, that is 0.25 moles of the solute is added. Okay, because you know that 0.25 divided by 1 kg means we will get 0.25 molar solution. Now the mass of the solvent we calculated here, we'll write here 2500 minus N into 60, and that equals to, we'll write here N. That is the number of moles. We'll calculate that first. Now cross multiply this, that is 1000 into N is equals to 0.25 into 2500 minus N into 60. Okay, this is what we get. Now first on this side we have to simplify this. 1000 into N. This 0.25 we can write 1 by 4. 1 by 4 into 2500 means it is 625. Simple calculation. N into 60 means N into 15 we get, because 60 divided by 4 we have to do. Now whatever the N terms are there, we'll take on the one side, that is, this is 1000 minus, this side will take, if it is N, minus N is there. Now if I take on this side, it will become plus 15 bracket, I will take N as a common, and then it becomes 625. Now N equals to, that is, you keep the N over there only, 625 divided by 625, the whole divided by 1015. Okay, and by that we get the answer. This is 0.6158. So this is what we get, the number of moles we get. Number of moles. So from number of moles we can calculate the amount of urea, or mass of the urea. Mass of urea required, we can write that equals to, that is number of moles which is added, that is 0.6158, multiplied with the molecular mass of the urea, that is 0.6158 into 60, and we get the answer, that is 36.95. Okay, now this is all about the one of the problem on the molality. Okay, now one more point you have to remember, that the molality is independent of change in temperature. If you change the temperature, the molality never get changed. The molality is not affected by the temperature. The reason is very simple, students. When you rise the temperature, the mass of the solvent never get changed. This is the reason. Reason is by changing temperature, the mass of solvent never get changed. Solvent do not get changed. do not get changed. Do not get changed. So this is what we get here, students. Okay. Hope you understood this concept of molality. In the next video, I'm going to explain what is normality and one of the important parameter, that is the gram equivalent mass or equivalent weight of any of the substance like acids, base, oxidizing agent or reducing agents. You can calculate the gram equivalent or equivalent mass of the salts. Let's see in the next video, students. Thank you for watching.